Hello everyone, it's John here from the Wingnut Laboratory. I'm the head designer and chief executive officer of Wingnut Industries. Anyway, we had quite a bit of success here today with the remote unit, the wingtip probe, if you will. So you may recall yesterday we had showed you the guts, the internals of the wingtip sensor system. Anyway, we've enclosed that today fully in a plastic tube. It's actually just the top part of a lightsaber unit from Walmart. I think it was $5.95. Anyhow, we've changed the pitot tube so that it's now just the carbon fiber, I believe it is, internal tube that comes with the Squirrel Freak 2 wingsuit. I've cut it down a little bit, and then with some hoses and a reducing plastic fitting, I managed to hook that up to the Airspeed sensor system. What you're looking at right here, that is a BME 280. It's a temperature and pressure sensor. So inside there you've got an Airspeed sensor, which is basically just a differential air pressure sensor, and then separately from that you have the BME 280 here, which measures the temperature and the pressure. Then of course inside will be Bluetooth unit and an accelerometer and the MCU, the Arduino Nano, and then some sorted wires as such. I've also today put on a wire attachment that'll eventually be hooked up to a battery. I think the battery is probably going to go on the helmet of the wingsuit. It's a fairly sizable battery, but I'll be experimenting with the ideal size once I get down to Arizona, hopefully later this month. What do we have over here? Well, we have the Arduino Uno right now, which I'm just using for testing purposes. That's an MCU as well, microcontroller unit. The actual unit we'll be using on the helmet is going to be the little Arduino Nano that you see here, quite a bit smaller in comparison. So on the helmet, what's eventually going to be is these four units right here. Got a GPS, U-Blocks GPS up in the corner, micro SD card reader and writer right there. We've got the HC05 Bluetooth unit and the Arduino Nano. So those will all be assembled into a little package on the back of the helmet. Okay, here's how it all works. So let's say you arrive at your wingsuit, and this is already on your helmet, and you have this inserted in the wingtip of the wingsuit. Well, let's just show you. I'm just going to plug this in. So this unit right here is not connected to anything. It's just got a USB cord for power, really. Nothing more than for power. Get that out of the way. So okay, so we've got this unit here. I go and you'll notice that over here the Bluetooth unit is blinking madly. It's looking for a partner right now. It only has one partner. I've set it up so it's only got one partner it's going to talk to, and that partner is going to get power here right about now. Let's see if we can get this thing in here. Okay, plugged it into the lamp. So then the lights start coming on in here. And what's going to happen is Bluetooth connections take a bit of time. But okay, we've already got now it's not blinking anymore. It's a steady. The LED is steadily on, so that means it's linked up. And now, if we go to the computer screen, you'll see we're starting to output data here. And I haven't formatted it in any meaningful way right now. It's just transmitting the raw data. And on the left, you see is the speed in knots. The next field at that 1 is the tilt of the angle, I guess, if you will, of the wingtip. The next one in, I think that's probably maybe millibars or hectopascals. That's six numbers, hectopascals, and the other one is the temperature in Celsius, 26 degrees. So what's happening right now is this unit right here is transmitting its info via Bluetooth over to this Arduino here, which is then plugged into the computer and then outputting that information on the screen. So let's see what happens if I raise the angle up. You can see, okay, we're up 25 degrees, 26 degrees, 29 degrees, 32 degrees. Keeps going up and up and up. Now the temperature and the pressure are not going to change because it's, well, the temperature and pressure aren't really measurably increasing or changing here at all, our default. So let's bring it back down to about 0 degrees. Now, I'm going to blow into the tube. There we go. So that was, well, we got up to 172 knots. Fair bit of pressure there. So demonstrated now the practicality of having the wingtip unit transmit its data to the helmet, and then now it's a question of displaying that to the wingsuit pilot. Anyway, so the concept is evolving. Stay tuned for more from the Wingnut Laboratory.